What we're starting with is well, we're just picking up where we left off yesterday. So we have 1 over 2x plus 5 is equal to x over 11x plus 8. Restrictions. Okay, so I'm not going to give them to you here. We're going to actually look at them. So restrictions for rational equations is any value of x that would make the denominator be 0. So if we plug that number in, and it would make the denominator be 0, we have a division of 0, we have to throw it out. Now, for the most part, finding the restrictions, actually listing them, is here nor there. Because if we don't list the restrictions, we don't do this part. What that means is we have to check them. We got to plug them back in and make sure that both sides equal and that the value we plug in won't cause a division of 0. So if we picked, and I just, for no real reason, I just picked negative 5 halves. Because if we plug it in here, 2 times negative 5 halves plus 5. Well, 2 times negative 5 halves would be negative 10 halves because we multiply with the top. Negative 10 divided by 2 is negative 5, and negative 5 plus 5 is. So this denominator would be 0. I'm dividing by 0, no matter what the top is. So that tells me that's a restriction, because if restrictions, if this denominator, 2x plus 5, is 0, it would cause a division of 0. Same is true with 11x plus 8. So here to find it, we're just going to solve for x. Minus 5 from both sides. So I mean 2x is equal to negative 5. Divide by 2. So it's telling me if I get an x value of negative 5 halves, we'd have a division of 0. That does not work. Same thing here. We minus 8. Divide by 11. X cannot be negative 8 11ths. Because if it is, we have a division of 0, doesn't work. Now, the reason I like putting the restrictions or doing those first is because it's telling me already, if negative 5 halves or if negative 8 11ths comes up as a solution, it tells us this is a solution. Well, we know it's wrong. It doesn't work. And it's not that we did anything wrong in solving. It's just that in the problem set and how we solve it, because that came up as a solution, we have to throw it out. It's an extraneous solution. And that's, don't know if it will, but if the ACT asks for the extraneous solution, what is the extraneous solution? It's asking for which one did we throw out as a possible solution choice. Because it's the same for geometry. If you solve and get a negative length, we have a positive, the length for the side of the triangle is 12 or negative 12. Negative 12 doesn't work. Even though, yes, that is the answer for solving, because it doesn't work in the original context, we throw it out as an extraneous solution. Does that kind of make sense? So that also gives you context for what extraneous solution is. Now, as we look at these here, we could do the cross multiply, and that works just well because we have 2 fractions. We can go through the proper mathematical route of finding the least common denominator, listing that out, and going through that there. Or we can start by looking at these two here, 2x plus 5, 11x plus 8. They're factors as far as they go. What would I need to multiply the left fraction by to get that denominator to go away? Yeah, 2x plus 5, yes? Because if we multiply our 1 over 2x plus 5 by 2x plus 5, we would indeed have 2x plus 5 on top end. Multiplication, no addition, subtraction, they would cancel. They would simplify. So these would go away. But what we do to one side, we have to do to the other. And we need to make sure and just check. I will check the right side. Will that 2x plus 5 simplify with anything on bottom? No, because 2x plus 5 and 11x plus 8 are not the same. Do we have any denominators left we need to simplify? Yeah, we have the 11x plus 8. Okay, so I'm also going to multiply by everything by and on the right hand side, the 11x plus 8 and 11x plus 8 will cancel. This is the same as the pure mathematical way to do it. We're just doing it piece by piece, not finding the whole expression we need to multiply everything by and then doing it. I think this is a little bit nicer. We take it part by part, see what simplifies. That way we don't add too many. Questions on this so far? Now let's see what we have left. On the left-hand side, we still have the 11x plus 8. And it's being multiplied by 1, which is just 11x plus 8. We don't have to put the multiplication of 1. On the right-hand side, we still have that x, and it's being multiplied with 2x plus 5. Now we need to solve for this here. Now on the left-hand side, the 11x plus 8, we can drop the parentheses. It's still just 11x plus 8. On the right-hand side, we can distribute the x. X times 2x is 2x squared. X times 5 is plus 5x. This is now a little bit different than what we had yesterday. Because we have what? We have this quadratic term, this x squared term. So if we have quadratic terms, we have variables with exponents greater than 1. We need to get this equation equal to 0. We need to get it equal to 0. Now what we move first, to get it equal to 0 does not matter. We can minus 11x from both sides, because 11x minus 11x is 0, leaving us with 8 is equal to 2x squared. And our 5x minus 11x is negative 6x. Well, still not equal to 0. Subtract 8 from both sides. Minus 0 is equal to 2x squared minus 6x minus 8. Questions on how we got here? Now we need to solve this. It is a quadratic, yes? Which is nice because we have factoring, quadratic formula, completing the square, graphing. Now, graphing is nice if we get integer results, yes? Now, there's a good likelihood we won't, at least get not one of them, if the number in front of x squared, our value of a, is different than 1. Here the value of a is 2. If we were to factor it, we need to look for what? A greatest common factor. Is there one? Yeah, so we could actually factor it out. Now, this is a side note. Are we actually caring about what it factors to? We're not caring about the factorization. We just want to solve for what values of x make this function equal 0, yes? We could factor it out or actually divide the whole thing out. And this works because if we divide it out, this is 0. This is x squared. This is negative 3x. This is 4. So we divide it out, yes? If I didn't, you don't have to write this. But if I didn't, we would just move that number to the front. I don't have space in front, but I'll put it behind it. Because it'd be 2 times our x squared minus 3x minus 4, yes? What does zero product property state? If 2 or more things are multiplied together to equal 0, one of them has to be 0. because that's the only way we can get 0 with a product. Two things multiplied together equals 0. One of them has to be 0. Is there any way I can make that 2 be 0? No, there's no variable next to it. It's just 2, which means the x squared minus 3x minus 4 has to be the 0 part. The 2 has no impact on that. It's just saying that we multiply it by 2, we still get 0. So we can actually divide it out. Because even after we factor this, it's still going to be 2 times those 2 sets of parentheses. Like, still, those 2 sets of parentheses are the only thing that can be 0. If we were actually factoring it, we just want it factored. We need that 2 because we need to get back to the 2x squared minus 6x minus 8. I'm just trying to find out what makes x be, or makes this whole thing be. We can get rid of the 2. Well, so really, even though a was 2, a is actually just 1, so we could factor it. And, or not factor, we can graph it. I'll show you both graphs here in a minute. Third term, 2 sets of parentheses with 3 spaces. Since the third term is negative, the signs are opposite. Factors of x squared are x and x. Factors of 4 are 1 and 4 or 2 and 2. 1 and 4. I'm going to put them here, but we actually wouldn't have 2 and 2. X plus 2 times x minus 2. That's the factors for a difference of perfect squares, because the middle term would cancel out. So we actually want 1 and 4. If I checked it for the middle term, x times negative 4 is negative 4x. 1 times x is positive x. Negative 4x plus x, negative 3x. Middle terms we wanted, yes? So we do have 2 things multiplied together to equal 0. So one of these 2 has to be 0. So the 2 solutions are negative 1 and 4. Questions on this here? I'll go back to it. This was our one starting equation, 2x squared minus 6x minus 8. There's the graph, and we can see at negative 1 and 4, it does cross the x-axis. Now, all right, and this is the one we actually factored and solved, yes? The 2 graphs are almost completely different, except for where it crosses the x-axis. All right, guys, focus in. Because if we look at the tables, at negative 1 and 4, the y values for both of them is still 0. The y values for every other point is different. We don't care. We're just trying to find out what value of x is going to make that function equal 0. Those still work. And this is also reinforcing why it's dividing that 2 out still works. Neither one of those is a restriction. And we're done. That's it. Questions on this here? We have 3 terms now. And cross multiplication is now out the window because we cannot do cross multiplication with 3 terms. But the way we've been doing it still works. Now, our restrictions is actually kind of nice for this one. Because if we look at the 3 denominators, they're all factored because they're x, 4, and x. And the only two places where we actually have a variable, that variable is just x, yes? And that denominator cannot be what? 0. So we'll solve that, okay? And it's just telling us that x cannot be 0. All right. Give myself a little more space. Now we need to figure out what we need to multiply through by to get those fractions to go away. What's something we can multiply by? What do you think? Take a guess. Yeah. Because since we do have that 1x on bottom, we can multiply through by x. Now again, some of the places where we get stuck is, do we multiply by x or x squared? Because that's the big thing, because x shows up twice, yes? I'm just going to do it once and see what happens. Because on the far right side, the negative 9 over x, well, we would have negative 9x over x. And this x would cancel with this one here just fine, yes? The middle, 7x over 4, the x over 4, not the same, they won't reduce. On the far left, we're going to get 5x over x. Well, this 1x here will cancel with this 1x here. So did we need more than 1x multiplied through? No, because we multiplied through with 1 and simplified out. If it had been x squared down here, it would simplify with one of them. They all did not cancel out completely, so we'll multiply another one through. But since there was only one of them there, they're gone. Do we have any denominators, bottoms of the fractions left? The 4, yes? So, okay. That means we're also going to have to multiply through by 4. So I find this one term at a time is nice because we do the one term through, see what simplifies. Well, the 4 in the middle didn't. So we can multiply through by that 4. It will cancel that last one out. And since all three denominators are simplified out, we can see what we have left being multiplied on top. Because we have 5 times 4 plus 7 times x is equal to negative 9 times 4. Well, 5 times 4 is 20. Plus 7x is equal to negative 36. So we would indeed subtract 20 from both sides. You gonna grab one? Yeah. I don't think you want this warm one. Questions on this here? That's not one of our restrictions. So we're done. You're welcome. Yes. Even if we did have a restriction, all we do is just cross it out because it can't equal it, so it's removed. If it turns out that all of our solutions are restrictions, we don't have any left over, it has to be what? No solution, because all of our solutions have been removed. Questions on this here? One minus 8 over x minus 5 is equal to 3 over x. All right, guys, focus in. So we have two places where the denominator can be 0. Yes? One of them is at x. Well, if that x is equal to 0, it gives us the denominator of 0, so it can't work. The other place is at x minus 5, yes? And we could solve it by adding 5 to both sides and figuring out that x is 5. Telling us that 5 cannot be 0. But really, x minus 5 is just saying what minus 5 is this number. What minus 5 is 0? 5. All right. Now we need to figure out what we need to multiply everything by. X. And? Yes. Because we can start off with x, and the x over here and this x would cancel. We also need the x minus 5 because for our middle one, the x minus 5 and x minus 5 would cancel. Did we take the 1 into account? Does it have a denominator? Does it have a bottom of the fraction? I mean, it's 1, but that doesn't help. It doesn't make any difference. Because what is the goal of this first step? Is to get rid of the denominators. We want to simplify those fractions. We do not want fractions. It makes this easier to solve. The 1 does not have a fraction. It's not a fraction. It does have a denominator. So that's not my focus. My focus is on the fractions, making them go away. So really what this leaves us with, because now the fractions are gone, 1 times x minus 5. Minus 8 times x is equal to 3 times x minus 5. Questions on this here? I would start simplifying. Because we could, but we would get to x. I'm going to write it, if we divided we'd get here. Because the middle term, that 8x, doesn't have an x minus 5 to simplify out. So x squared minus now we need to get it equal to 0 because we do have an x squared term. But before we do that, we do have like terms on the same side of the equal sign. So negative 5 minus 8. Yeah. Yes. Mm-hmm. Because it's going to be easier to get it equal to 0 if we don't have two like terms sitting next to each other. Now, the direction we move everything over to doesn't matter. But the big thing I focus on at this point is making sure whatever the variable with the biggest exponent stays positive. And whichever one has the least number of moves. Because here I could move the x squared negative 13x over, giving us a negative x squared minus 16, or negative x squared plus 16x minus 15. Or if we add 15 to both sides, x squared minus 16x plus 15. Which is the same thing, it's just the signs were all flipped if we went the other direction. Now we just need to get the 3x to the other side. So we can subtract it from both sides. And then add 15. Because the whole goal at that point is just to get it equal to 0. We can graph or factor this. Either one's going to work. Which one do we want to do? We can graph. Because if we graph, I'm going to grab the graphing calculator or Desmos, because you should have it on the ACT, and we're going to type it in. X squared minus 16x plus 15. Once we type it in, we hit graph. Now we can see it is crossing the x-axis at 1. And when x is equal to 1, the y value is 0. So that's a solution, yes? Now, because it's quadratic, agreed to, we should have two solutions. What are the factors of 15? Because we do have 3 and 5, yes? Or 1 and 15. Well, negative 15 is not a solution because it's not 0. But when x is equal to 15, the y value is 0. So the solutions are x is equal to 1 and x is equal to 15. And because they're both, because neither one of those is a restriction, they both work. If we factored it, 2 sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and match the sign of the middle term. So negative and negative. Factors of x squared are x and x. Then we'd take 1 and 15. Set both of them equal to 0 and both methods work. You don't have to do both. You just have to do one or the other. Questions on this here? We feel good with this so far. Because hopefully, all right guys, focus up here, focus up here. The bigger thing to focus on, hopefully you're seeing step by step why we're doing which step at each order. Because that's more important than what the numbers are. Because if we know, looking at this next one, we can look at our restrictions first. And really that's telling us that x cannot be 0. 2 places where you have denominators with variables, it's just x and x. So x cannot be 0. That would be a restriction. Now we know we need to multiply through by something to get those denominators to simplify out. X and 2. First fraction, our x that we multiplied by, and the 1x on the bottom would cancel. In the middle, the 2 and 2. last one, the x and x. Leaving us with 3 times 2 plus 5 times x is equal to negative 12 times. Huh? Yeah. So we would subtract 6 first. Minus 5x is equal to negative 30. So negative 6. Questions on this here? Questions on anything so far? And really, the rest of this isn't any different than what we've been doing. Yeah, so we do x and x minus 4, go through and solve. Now, we're not going to do those last two, not because they won't be helpful. They could be, but when we come back on Monday, we're going to do more of these. So we're going to do more solving. We're going to see more of these. So they're going to be a little more different. We're going to have to factor. We're going to have to simplify. 6 through 9 is our cross multiplying. You can do cross multiplying, least common denominator. Either one works. 19 through 22, we're solving multiple terms. 22 does have a restriction. 22 has a restriction, so pay attention for that.